Hello, my name is Susana Lavado and I'm a researcher at Nova School of Business and Economics of Nova University of Lisbon, Portugal. Thank you so much for watching this video where I will be talking about my research paper entitled Human Oversight of Algorithmic Decisions, a Post-Deployment Empirical Investigation, submission number 4411. This work is a collaboration with Charles Wan from the Rotterdam School of Management of the Erasmus University and Leid Zejnilovic, also from the Nova School of Business and Economics in Lisbon. We have been developing this work in partnership with the Portuguese Public Employment Services, or in Portuguese, Instituto de Emprego e Formação Profissional. So our research question is, how does human-machine interaction in human-in-the-loop systems evolve through time? So basically we are trying to understand how the hybrid decision-making that it's typically done in systems where humans and algorithms interact evolve when the humans get more time or more used to dealing with the algorithms. So human-in-the-loop systems, as I was saying, are hybrid human-machine systems that typically combine automated algorithms or artificial intelligence with human oversight or intervention. This human oversight is perceived as a safeguard against violations of the rights of data subjects in recent European Union's regulations, such as the GDPR, that says that people shall not be subject to exclusively automated decisions that significantly affect them, or the EU AI Act, that requires that there's some level of human oversight for high-risk systems, saying that, for example, humans should be able to decide in a particular situation not to use the high-risk AI system or otherwise disregard, override, or reverse the output of the high-risk AI systems. And of course, low-risk systems are also encouraged to follow these guidelines. So basically, the systems are being associated as having higher accuracy, higher reliability, also higher accountability, as the human is responsible for the final decision, and also as being able to keep some ethical safeguards compared to fully automated systems, and also legal safeguards. However, they might not be the silver bullet they are heralded for, and we still need to understand more how these systems work, and especially how humans behave when interacting with algorithms in such systems. So today I'm going to talk to you about a human-in-the-loop system that is being using at the Portuguese Public Employment Services. This is basically a system to predict the risk of long-term unemployment. So their main role is to assist employment counselors in proactively preventing candidates from transitioning into long-term unemployment. The system predicts whether an employed person has a high, medium, or low risk of becoming LTU, and people that are identified as high risk of becoming LTU receive extra help from the Public Employment Services counselors. So they receive extra trainings, or for example, a personalized counselor that is dedicated to their process. We collaborated with the Portuguese Public Employment Services to improve the previous system that was in place since 2012. Basically, our idea or our task was to create a new system that solved the limitations of the previous system, and those limitations were mainly three. So on one hand, the system was outdated. It was a machine learning model that was created back in 2012, and it was never updated, so it was obviously time for updating it. Also, it did not consider the path of an individual within IFP, so it wouldn't consider whether the individual would have applied for different jobs or did different trainings, and even it didn't consider where the person was already unemployed for 6 months, 9 months, or even 11 months, so at the brink of becoming long-term LTU, long-term unemployed. Also, and this is especially relevant for this presentation, the system contained barriers to counselors' interaction. So basically we conducted focus groups with the counselors at IEFP and realized that they were not truly engaging with the system. So they most of the times accepted the algorithmic decision without much reflection. They didn't really understood why the algorithm would make a given decision, and they would basically just automatically accepting anything that the algorithm would suggest. And obviously, since we are considering this human-in-the-loop system, this was far from ideal. And so our goal was to actually try to improve this situation. So basically we created a new system which introduced some changes that hopefully would improve this hybrid human-machine decision-making. So basically we created a more intuitive and easy-to-use interface for counselors. We facilitated human oversight by removing barriers to override the algorithmic suggestion. And we established that there would not be any default automatic classification of risk. So counselors would need to select the risk level deliberately. So they would see the recommendation, but then they would have to actually select a risk level by themselves. Also, we added an explainability layer, which was powered by the shape factors, so that each individual decision was explained to counselors at some level. Also, when deploying the new system, we made sure that counselors were provided training, explaining how the system was built, its potentialities, but also its limitations, and explaining to them that their oversight was actually really important because the system was going to make errors. And also we presented the interface that the counselors would interact with, including the explainability layer, so that any questions or any barriers to that use would be solved. And this was actually apparently effective. So the override of algorithmic decision rate was 1.6 in the previous system. When we deployed the new system, we did a pilot study, and during the pilot study, the override rate actually increased by a huge margin, so it rose to 32.2% during the pilot. But as you know, pilots are particular times, so basically counselors had a very strong focus on this particular system that was deployed, and they knew that the system was being tested. They had incentives to actually interact with the system. So the question is, what happens after this very special pilot phase when the spotlights are no longer into the system and counselors go back to their business as usual, let's say. And so our question is actually, what was the override rate after the deployment of the system? So basically we wanted to understand if the rate of overriding of machine decisions in this human-in-the-loop system was sustained through time, or if it tended to decrease as the months would pass after deployment of the system. And why is this important? So why should we analyze interaction of the counselors with the algorithm through time? We believe that understanding how time affects human-in-the-loop systems may actually allow us to design policies to sustain meaningful human oversight. So basically we want to understand if there are particular points in time where we should actually reinforce the message that counselors should retain their agency, should retain their autonomy, and should keep oversighting the algorithm, and they should not dismiss themselves from that role. So we also want to understand if certain decisions lead to more or less oversight, or if some counselors' profiles are also more related to oversight. So in terms of the dataset that we used for our research, we basically analyzed 18 months of data since the deployment of the system in June 2021 until the end of 2022. We analyzed data from 53 unemployment centers and 1,113 counselors. We also analyzed the outcomes, or at least the decision of the counselors in almost 2 million decisions, so whether they had overridden the algorithm or not. Our variable of interest was, as I mentioned, the rate of decisions that were override per counselor. Let me now tell you about our main findings. So basically we found that the average override rate tends to decrease over time. As you can see in the plot to the left, where I'm showing the months in the x-axis and the override rate at the y-axis, we basically see that counselors start to override very highly, so close to the pilot values, close to 30%, but then there's a sharp decrease as the months go by. So basically in the first 6 months, the override rate tends to decrease by around 2% every month. Then it starts to plateau, more or less 6 months in, and stays close to 0.13 in later months. We don't know exactly what would happen if this is if it stabilizes here, but it seems to show that there's some tendency to actually get to be around 0.12 and 0.14. Also, and this is, I think, an important nuance, we also investigated whether the decrease was homogeneous towards counselors. And what we did was basically we compared the override rate for counselors in the first month compared to their override rate in the last month. So for each counselor, we compared the difference between their override rate in the last month and in the minus the override rate in the first month. And so each counselor would have a rate of override different, let's say. And what we found was that most counselors overrode the algorithm less in the last month of the dataset than in the first. So consistent with the results that I was showing before, we see that 75% of counselors actually decreased their override rate through time, overriding the algorithm less in the more recent months. But then we do have some counselors that are overriding more in the last month compared to the first one. And this is surprising, and it shows that there's some heterogeneity in terms of the behavior of the counselors. Maybe it also suggests that some counselors are, as they are interacting more with the algorithm, they are maybe trusting it less. So basically, as they are interacting with the algorithm, maybe they realize that, or they think that the algorithm is making some mistakes, and they are actually being more vigilant or doing more, trusting the algorithm more, or accepting the algorithmic decisions less as time goes by. And so we actually, one interesting research question is actually to understand how these two groups of counselors are different, and why is this different behavior occurred. However, this is obviously still preliminary data, and actually we want to deepen this work. So I'm going to tell you a little bit more about what we plan to do in our future work. So basically, we want to disentangle the effect of trust or distrust and an interest in the override of algorithmic decisions. So basically, if people are overriding less, is it because they are starting to trust the algorithm more? They are starting to actually understand that it might be sometimes or many times correct? Or is it because they are just not interested anymore? It's not the novelty effect washed over, and it's not a novelty system anymore. And so they are just, trying to get over the steps that they need to do as soon as possible. And so we actually want to understand what are these two trends and what is the weight of the two factors. So the fact that we see that some counselors are now overriding more than they were overriding this in the beginning maybe hints that some counselors are trusting the system less, but we want to truly understand these two factors. We also want to explore how the overriding of the algorithmic decision translates into better or worse decisions. Obviously, overriding by itself may not be good if the counselors are overriding correct algorithmic decisions. So basically, it's not positive by itself. So actually, we want to see what is the effect of overriding, who is more often correct, and also what are the factors that lead to a correct overriding of the algorithmic decision or an incorrect one. Also focusing on, for example, the shape factors that are being showed to counselors. So thank you so much for watching my presentation. I hope you found it interesting, and I'm looking forward to see you in the conference in July. Thank you. See you soon.